This video explains how to calibrate and test a flare system. Before calibrating your system, ensure that all sensor units within RF range of the calibration area are verified as operational by Sensor and Test Units, or SATU. If unsure of the RF range, confirm that all sensor units are operational by a green status light in Network Manager software. You have at least one configured personal protection device, or PPD, with a fresh battery and a PPD to USB adapter cable. The Flare software is operational. The Calibration Tool software is installed on a Windows tablet and includes a copy of your Flare database called MDB file and map files. To reduce the time required to calibrate and test your system, it is critical that you read the Flare System Administration Manual, Section 5.12, and Flare Calibration Tool Overview before starting. Whenever performing calibration or testing, always follow and obey the applicable workplace safety rules and regulations. Calibration and testing is performed using a PPD connected to a Windows tablet running the Flare Calibration Tool software. During testing, the Flare Calibration Tool communicates with the Flare software via the PPD-sensor unit RF link. The calibration tool, when running on a Windows tablet, supports standard touchscreen gestures. Tap to select CZones and menu options. Drag to move the map around. Pinch to zoom in or out. The calibration process generates and records PPD activations throughout the entire site. The system records the signal strength of each PPD activation received by each sensor unit and stores it in the Flare database for later comparison. Calibrate one general area at a time, example, an annex or wing. During calibration, you can easily switch to test mode and verify the calibration by confirming that an activation returns the correct location. Note, when calibrating a system that is fully or partially operational, the Flare system will still process and display individual PPD duress alarms. However, it is not recommended to calibrate when other PPDs are being activated, as it slows down the calibration process. Before starting the calibration process, attach the PPD to your belt. You must wear the PPD in the same manner as that of a regular user. See the PPD user instructions for correct placement and usage. Connect one end of the adapter cable to the PPD. Connect the other end to the tablet. Launch the Flare Calibration Tool. Verify the PPD connection. The circle should remain green, indicating the PPD is connected. If the circle turns red, the PPD is not detected. Load the database for your facility by clicking Open Site and selecting the database. Once the database is loaded, you need to configure the number of samples the system records during each PPD activation. Click Menu. Select a calibration sample size of 8 and click OK. Typically, 5 to 7 samples provide a good average of responses. Some samples may be rejected as outliers. The Flare software requires a minimum of 3 samples. Do not move from your spot when sending or receiving calibration samples. Note, using a sample count of more than 8 does not necessarily improve the response average and may slow down the calibration process. Next, confirm the operation of the calibration tool. Select a CZone and click Calibrate while observing the Flare software. After confirming basic communication, select Clear Samples. Proceed to the general area. Display the area on the tablet by selecting your building's map from the drop-down menu. Zoom in and move the map as required. Enter calibration mode by selecting the Cal Mode checkbox. In this mode, selecting a CZone on the map will automatically activate the PPD for sample collection. Proceed to a CZone location, shown on the map as a blue square. On the tablet, select the CZone. The PPD will start to beep, 1 beep per activation, approximately 1 second apart. Rotate your body incrementally so that by the time the beeps are done, you have rotated the desired amount. You can rotate in one direction or back and forth. However, it is critical that you do not rotate more than 180 degrees. Observe the number of current samples. If there are less than 6 returned samples, you can redo the calibration to add additional samples, for a maximum of 10, or clear them and start over. The CZone square will turn green when the number of samples reaches 7. CZones are individual calibration points. They can be arranged in singles, duals, or quads. The pattern used during database creation is based on experience and room sizes and does not affect the number that need to be calibrated. Note, if the number of samples stays at 1, a sensor unit may have gone offline. The Flare software will prevent calibration until the sensor operation is restored. Deciding on which CZones to calibrate is a function of required location resolution and architectural layout. For example, consider a row of inmate cells. Calibrate a CZone in every second cell, providing you still calibrate a point at every required resolution distance. In a multi-floor building, you would then calibrate a CZone in alternating cells on the adjacent floor, i.e., not directly above or below. Next, test the points to see if the necessary location accuracy is achieved. If the required accuracy is not achieved, calibrate more CZones. In this example, the next step would be to calibrate in every cell. When selecting CZones, do not attempt to calibrate ones that are not physically accessible. Depending on the number of CZone points being calibrated, use one of the following patterns. 180-degree rotation. Use when 1 or 2 points in a group, room, or area are selected for calibration. This is the most common pattern since rarely do you need to calibrate more than 1 point in a CZone pair or quad. 90-degree rotation. Use when 3 or more points are selected for calibration. For example, a large area, or you are having trouble meeting the location accuracy requirements. Once an area is calibrated, test it before proceeding to the next area. When testing, you can test both calibrated and uncalibrated CZones. Switch the calibration tool to test mode. In this mode, you can quickly select a CZone by tapping it, rather than having to select the test point from the pop-up menu. Stand at the CZone location and select the CZone. It will turn red. Wait a few seconds. A translucent red circle will appear, with its center being the system-reported location. Test the other CZones distributed throughout the area. Use different PPD orientations when testing. When deciding if the reported location test results are valid, note the following considerations. Line of sight to the actual location is usually considered a pass, assuming that the distance from the actual location is reasonable. The accuracy specification of your site. There are different resolutions specified indoors and outdoors. In open areas or large rooms, a reported location in the same area or room is considered a pass. Floor jumps and indoor-outdoor jumps are considered fails. Note that partial floors like atriums and catwalks are considered single open areas. If the test results meet your accuracy requirements, you may proceed to the next area. If the test results do not meet your accuracy requirements, you will need to calibrate additional CZones or possibly recalibrate poorly calibrated ones. You can clear the samples from any CZone, for example, if the calibration was done incorrectly or if you accidentally selected the wrong point. To clear the samples from a CZone, exit Cal mode or test mode if currently selected. Tap the CZone and select Clear Samples. The CZone will turn blue, indicating that the samples have been deleted. You can now either calibrate the CZone again or move to a different one. You should only calibrate enough points to meet the accuracy requirements of your site. Calibrating additional points when the accuracy requirements are already met is unnecessary and may not improve the performance of your system, not to mention uses up additional time and resources. After the entire site has been calibrated, system verification against an acceptance test plan or ATP is required. Contact your Senstar technical representative for more information.